All right. So remember, for part B, to find a critical point, what we have to do is we have to find the derivative, right? And then we have to figure out where the derivative is either equal to 0 or undefined, okay? And so let's do this function here. So we're going to find the derivative of f of x, so f prime of x. And here we have a chain rule situation, right? So I'm going to take the derivative of the outer function first using the power rule. So I'm going to do 3, then the inner function stays the same, take away 1 from the exponent, and then I'm going to multiply that by the derivative of the inner function, which is just 2x, right? The derivative of x squared minus 1 is just 2x. Okay, so let me simplify that a little bit while I set it equal to 0. So I'm going to set this equal to 0, and I'm going to multiply 2x times 3. So I'm going to get 6x, x minus 1 quantity squared. Okay, so a couple things here. We could factor this a little more because it's a difference of squares. So if you wanted to, you could turn this into this. Okay, but then that would be quantity squared. So there's actually a couple of those. So you can do it a few different ways. Or the other thing you can do is just set this equal to 0 and solve. Right. And so if you were to solve that, you would take the square root of both sides, and then don't forget the plus or minus when you take the square root of both sides. And so you'll end up with x equals positive 1 and negative 1, right? Plus or minus 1. And that's the same thing you'd get if you factored, right? You'd get x equals positive 1, or let's do negative 1 first, since this is going to yield a negative, and then this, we'll change the sign there, so that'll be a positive 1. Okay, and then the other value we'll get is if we set 6x equal to 0 and divide by 6, we would get x equals 0. Okay, so these are our three those are our three critical points. Okay, and then once again, there are no values where this is undefined, right? Because our domain is negative infinity to positive infinity. There's no value for x that I can't square, that I can't multiply by 6, that I can't multiply together. There's no restriction there, right? There's no limitation on what we can raise to a power of 2, what we can multiply, and so what we can add and subtract. And so anyway, so these, we don't have any undefined values in this case. We just have values where the derivative is equal to 0. Okay, so let's check out the graph and see at negative 1, 0, and 1 what's going on. So we can graph on Desmos or a graphing calculator, and we can see that on this graph at negative 1, we can see that that's not an extrema, right? It's kind of one of those fake out where the graph comes down, it flattens out, maybe looks like it's going to turn the other direction, but then it keeps going down. Okay, at 0, we have a local minimum, right? Where x equals 0, we have a local minimum, and then at positive 1, we have another one of those fake out points, right? Those are called points of inflection, but it's not an extreme. Okay, all right, so we just have one local minimum, and it's actually an absolute minimum as well, right? Because this is the lowest that the function goes ever, right? And so so that's the local and absolute minimum, and that happens at x equals 0. All right, so back to here. So we have an absolute, and any kind of minimum is a local min or max. So so this is also a local, but we'll call it absolute min, and that implies local, right? All right.